In this video, we're going to talk about the applications of Pythagorean theorem and really going to see a lot of examples of word problems in real-world situations where Pythagorean theorem is going to be applied. So let's take a look. First question, we have a Bethany that has a circular table that she needs to carry inside of her house to paint. Her front door is a rectangle and has a width of, so I'm going to go ahead and start sketching. So a circular table needs to go through a rectangular door that has a width of 36 and height of 80. Okay, those are my measurements. If the table has a diameter of 86 inches, will it fit through her front door? So diameter is 86 inches. So my thinking is, if it's 86 inches, she definitely cannot just go through the door. She's going to try to use this measure right here, the diagonal line, to see if it will fit. And that's our focus. What is C value? So when we are creating this rectangle that we have seen before in our application questions earlier this week, this is the diagonal line through the door is our hypotenuse. All right, we're ready to get it started. Plan and work. Your 36 and 80 are your leg measurements. So 36 squared, 80 squared will give us C squared. That would be, yes, numbers are very large, but you have your calculators that you should be utilizing. And as always, you just kind of have to just be careful, write things down, so when you plug in these numbers in the calculator, you are very successful and don't have little typos. And when you take the square root of that 7,696, we will have 87 and 7/10. This particular question and set of questions, or this particular one, does not have it rounding for us, rounding rules for us, but we have been rounding to the nearest tenth, so we will go ahead and continue with doing that. My solution, yes, C equals 87.7 inches, so table top will fit through. All right, so as you can see, this is really, absolutely real life scenario. You're going to be moving to the dorm. You're going to be moving to your new house. How are you going to get your furniture in? That's very valuable information. All right, number 2. If you love baseball, this is your type of question. Absolutely. So Greg plays baseball in the field where baseball diamond is a square. So the baseball diamond, it's definitely a term from baseball, is a square. So I'm not going to draw a diamond. I'm just going to draw a nice square for us. So this is what we're working with for this question. With each side of the square measuring 90 feet. So 90 by 90. Okay. If the baseball is thrown from home plate to second base, that's requiring a little bit of explanation. So there's home plate. This is, I guess, the beginning. Then there's first base, second base, third base. And so a lot of times, I'm just going to turn this around, just a quick little lesson, and you can see it's not really good square. They start at the home plate, and this is kind of how the game goes. Anyway, so what they are doing is they are traveling, or the baseball is thrown from a home plate to second base. Right here, and then right here. So I'm going to actually use my highlighter to kind of show you. So they are saying the baseball traveled here, and the baseball traveled here. Oh, you see how the application question just kind of went up and it's a little challenge? So they're not wanting for us, we need to find the hypotenuse, we need to find this little diagonal value, C, and then we need to add leg from second to third base. Oh, you don't see it. I didn't get everything in my video. Okay, so yes, we can see that, yeah, we have to find the C value, the hypotenuse, but also in order for us to see to answer the question, thrown from the home plate to the second base and then from second to third. So how much this baseball has traveled. And so let's get started. So as you remember, we had this scenario just yesterday. When you have a right triangle with two congruent sides, we call this isosceles, but we don't treat them any different. We will say, hey, this is leg A, leg B, got it. We got things taken care of. So this is 8,100 and another 8,100 for 16,200. So yes, large number. And we're taking square root of this value for 127 3/10 of a foot. And so, yes, this is our hypotenuse. But in order to truly answer this question, how long or how far the baseball has been traveling, we have to add the hypotenuse plus the leg value. So we know it's 90 by 90 by 90. So that's going to give us the total of 217.3 feet of travel. Very, very good question. And let's take a look at the examples from the back. We're going to try to get as many answered as possible. I think number 3 is not going to be a challenge for us, so I'm going to go ahead and scroll to question number 4. A little bit interesting application. So we have an isosceles triangle below. So we know what isosceles means right here. That means these two are congruent. Each side measures 13 meters. So this is the value, 13 meters. It says if the base of the triangle, this is the base of our triangle right here, is 10 meters. What is the height? So x that we have, that's what we are inquiring about right here. This is our value. What I would like for you, my friends, to do in this situation, please redraw and only focus on that right triangle properties. Okay, so I'm going to relabel 13. This is x. I'm going to go ahead and label. This is my B value. I have no clue what this is. What is the measure of this? And I also want for you to think of, well, what is this measure? Is it going to be 10? No, it's not going to be 10. 10 is the whole length. If we only take in this side, the length here would be 5. Super important detail. And so now we've seen this is our C value, this is our A value. We're looking for leg B. And so when we set up our equation, we know how to plug in our values. 5 squared, we're looking for B. 13 squared, 25, 169. We're subtracting 25 from both sides. B squared would be 144, and yes, we know very well that that means B equals 12. Super important. I want to make sure that you are comfortable with that. Next question that I would like to explain would be question number 7. My focus today is really on unique questions that we have not seen before. So if you glance at number 5, it's a square box. We have seen this before. I do want for you to answer those by yourself, but I just want to focus on the ones that we have not seen. Question number 7. These questions, like question number 7, are reminding you of what we started this week with. We started this week with models of Pythagorean theorem. So if you're wondering what is happening here, remember that when we're working with our Pythagorean theorem, just like we did earlier, we're taking each side to the second power. Okay, we're taking each of these sides to the second power. We're creating, so whatever is this measure multiplied by itself, we're creating a square. We're taking it to the second power. Okay, so that's why these squares are representing the measurement in the property of Pythagorean theorem. All right, so let's dive into question number 7. So if the perimeter of square 3 is 36 units, all right, I'm going to go ahead and start labeling. Perimeter is 36. And perimeter of square 2 is 48. Perimeter is 48. What is the area of square 1? All right, so here we are focused on many different properties. If it is a perimeter, what do we know about perimeter? Perimeter is all about adding the sides. Since we do work with the square, we know all of the sides are congruent. So in order to find one side, you would divide 36 by 4, and that's going to give you 9. Side 3 equals 9. So if we do the same thing with perimeter for square 2, 48 divided by 4 gives us what? 12. Yep, that is correct. I hope you were thinking. I hope you were not just waiting for me. And so now we are ready to plug in our values in order to find the value of this side right here. And so 9 squared, 12 squared, going to give us c squared, because this right here is our largest value. 81, 144 will give us 225. Square root of 225 would be 15. By the way, if you did not recognize this earlier, this is our Pythagorean triple. This is the product of 3, 4, 5 times 3. And so we're not quite done. We actually did not really need to find C, because if C is 15, the area would be 225. So area would be 225 units. Okay, so I'm going to stop at this point. I'm giving you some additional explanation of these questions. I would like for you to challenge yourself and tackle these 4 questions that you are seeing on the note right now for the sake of practice and just being comfortable with these types of questions. So please pause the video and take time to answer question 3, 5, 6, and 8. Once you unpause the video, you will see your answers, and it's a great way to check yourself before you complete a graded assignment for today. All right, hopefully you took time to work on these questions, and I just wanted to show you what the answer should have been. So I want to make sure that you didn't stop after you found the value of C. There's additional question. We talked about the area, so hopefully you were using this. If you're struggling with why I got this answer and you want for me to explain it in a little bit more detail, please reach out to me. If you're in the classroom, I am right there available. If you are at home, you can email me and I will explain these questions in more detail.